Go on any four-wheel drive Facebook group in Australia and ask about ECU tuning. Within 10 replies, you will have someone swearing their Hilux pulls 50% harder since the Remap, someone warning you the whole thing is a scam, and at least one post telling you to just get a Stage 2 package with the DPF delete while you are at it. I'm AJ, a TMR-approved compliance engineer, and I want to cut through all of that because a significant percentage of people spending money on performance tunes are buying something between nothing and a shorter engine lifespan dressed up in a dyno sheet. Let's start at the beginning and build the picture properly, because the conversation about ECU tuning gets compressed into marketing language almost immediately, and the technical foundation gets lost. Your engine's ECU is a computer that controls every critical operating parameter: ignition timing, fuel delivery, boost pressure on turbocharged engines, rev limiters, throttle response, idle speed, fueling corrections for intake air temperature and barometric pressure, and dozens of other variables. Every time you turn the key, your ECU reads sensors across the engine and adjusts these parameters in real time to keep the engine operating within its designed envelope. The factory map loaded into that ECU is not the peak of what the engine can do. The manufacturer's calibration team knows exactly how much power they can get out of that engine. They are not giving it to you by default for several reasons. First, fuel quality is not uniform across Australia. The calibration has to work on pump fuel in Broken Hill in summer and premium, unleaded in Melbourne in winter. Second, the engine needs to survive the manufacturer's warranty period across a wide range of operating conditions: high mileage, poor service intervals, extreme heat. Third, emissions compliance targets have to be met across the range. And fourth, in many model ranges, the same engine platform makes different power in different model variants. They detune the base model to create a product hierarchy. This means real power is available through remapping. That is not a marketing claim. It is an engineering reality. But the way that power gets unlocked matters enormously. A proper dyno tune and a generic flash tune are not the same product. The marketing language makes them sound equivalent. They are not, and the difference matters for your engine's longevity. A proper load-bearing dyno tune works like this. Your vehicle goes on a rolling road dynamometer. The tuner attaches a wideband lambda sensor to your exhaust to read actual air-fuel ratios in real time. They attach a boost pressure gauge, an exhaust gas temperature probe, and often a NOx sensor to detect detonation. Then they run your engine through a series of load sweeps, from light load to full load, across the rev range, measuring what the engine is actually doing at every point. They adjust timing and fueling in the map incrementally, checking the effect of each change on the measured data until the engine is running optimally for its actual hardware state on that day in those conditions. That process takes 3 to 6 hours for a diesel. It is done on your specific vehicle with your specific hardware at your current mileage. The result is a calibration that was validated against real sensor data. A generic flash tune is different. Someone, often a tuner, sometimes an overseas calibration company, has written a base map for a common vehicle and engine variant. They upload it to a module or directly to your ECU without running your vehicle on a dyno. No wideband, no exhaust gas temperature measurement, no boost verification. The map might be a good base map written by a competent calibrator, but it has never been validated on your actual engine. Your engine might have 70,000 kilometers of accumulated wear on the turbo. Your intercooler might have a small internal leak you are not aware of. Your injectors might be slightly tired. A generic map cannot account for any of that because it was never run on your vehicle. The power figures on the dyno sheet that came with the tune, they were measured on a different vehicle entirely. Now, I want to cover the part of the tuning conversation that the modification industry is very quiet about because there is a significant amount of money changing hands for work that is illegal on Australian roads, and the people doing the work are largely insulated from the consequences. DPF deletes and EGR deletes. The diesel particulate filter captures and periodically burns off particulate matter from diesel exhaust. The exhaust gas recirculation system recirculates a portion of exhaust gas back into the intake to reduce nitrogen oxide emissions. Both are fitted to your vehicle as a mandatory condition of it meeting Australian design rules for emissions. Both are considered part of the vehicle's certified configuration. Removing, disabling, or bypassing either device is illegal for road use in Australia. This is not a state-by-state interpretation. Federal environmental law, specifically the Motor Vehicle Standards Act and the National Environment Protection Measures, prohibits the removal or defeat of emissions control equipment from vehicles used on public roads. State transport legislation additionally prohibits operating a vehicle that has been modified from its certified configuration without appropriate certification. I understand why people do it. DPF regeneration cycles cause fuel dilution in some engine designs. EGR valves on high mileage diesels clog and cause idle issues. These are genuine problems, but the legal solution is to service or replace the component, not to delete it. The argument that everyone does it and the police don't check is not a legal defense. It is a risk calculation. And here is the part that should concern you most. The tuner who does this work has you sign a form saying the modification is for off-road use only. That form transfers the legal risk to you and removes it from them almost entirely. When the vehicle gets defected, when the insurance claim gets assessed, when the fine gets issued, it is your name on the registration, your vehicle on the road, and your problem to deal with. Here is the technical reality that the tuning conversation skips over almost universally. Your engine's factory components were designed and dimensioned for a specific power output range. Every component in the fuel delivery, forced induction, and cooling path has a maximum operating point beyond which it degrades rapidly or fails. Fuel injectors have a maximum duty cycle. The percentage of time the injector nozzle is open per injection event. Factory diesel injectors on most common rail four-wheel drives are typically sized with a safety margin of around 20% above the factory power requirement. Beyond that, the injector is running so close to open that it loses fine atomization control. Fuel distribution across cylinders becomes uneven and combustion quality deteriorates. The engine still makes power, usually, but it is doing so with compromised combustion that accelerates wear on piston crowns and injector tips. The fuel pump has a similar ceiling. At maximum delivery demand, pump cavitation can begin, fuel pressure stability deteriorates, and the engine starts to experience fueling drop-off under sustained hard load. The turbocharger is the component people most often treat as infinitely scalable. It is not. A turbocharger is matched to an engine's airflow requirements within a specific operating range called the compressor map. Push a turbo past the right-hand edge of its map, and it enters a condition called choke. The compressor wheel can no longer accelerate the air volume being demanded of it. Boost pressure collapses under load, power drops, and exhaust gas temperatures rise sharply because the engine is now running lean. Continue doing that repeatedly and you destroy the compressor wheel and cook the turbine side through sustained overtemperature. The intercooler has a thermal saturation point. Under sustained hard load, if the intercooler core cannot reject heat fast enough, charge air temperature rises, air density drops, and the ECU needs to pull timing to prevent detonation. Power drops. The engine is protecting itself from a cooling problem you created by asking for more power than the intercooler was sized to handle. Given all of that, here is how to approach a performance tune properly. The first question is not, how much power can I get? The first question is, what is the hardware limit of my current setup? And how much power can I make safely and sustainably without exceeding those limits? For most common rail diesel four-wheel drives, a Hilux, a Ranger, a Triton, a Prado, the factory hardware can typically support a modest power increase of 20 to 30 kilowatts above factory through a proper dyno tune alone. Within that range, you are not exceeding the fuel system or turbo limits in normal use. The tune is working with the hardware. If you want more than that, if you are genuinely chasing 40, 50, 60 kilowatts of additional output, you need to have a hardware conversation first. That means at minimum an upgraded intercooler for improved charge air cooling, and likely an upgraded high-flow fuel pump and injectors depending on the platform. Depending on the power level you are targeting, you may also be looking at a larger turbocharger, which changes your compressor map and the way the engine responds in the rev range. The sequence is hardware first, tune last, not tune first and hope the hardware holds. The other thing to ask your tuner before you commit is simple. Can I see the dyno sheet from my vehicle on the dyno with my vehicle's registration number on it? If they cannot produce that, or if the dyno sheet is from the same model, you are buying a generic flash tune dressed up as a dyno tune. That is not a knock on all tuners. There are excellent calibrators in this country who do honest work, but the market also has operators who charge dyno tune prices for flash tune work, and you need to be able to tell the difference. Before you book a tune, before you buy a flash module, before you spend anything, have an engineering conversation about what your setup can actually support. Know what your current turbo's compressor map looks like and whether it has headroom for more boost. Know what your injector duty cycle is at current factory power. Know whether your intercooler is a genuine performance unit or a stock-sized item that is already close to its thermal limit in summer. If you have that information, you can make a genuine cost-benefit assessment of what a tune will actually deliver on your specific vehicle, and what hardware you need to change to safely chase more power. If you do not have that information, you are buying marketing. For anyone who is planning a tune or figuring out what supporting hardware changes make sense before going near an ECU, go to totalengineeringmods.com.au and ask Willie to look at your setup. It is a free check on the engineering side before you commit money to a tuner. What are you running? And has it been properly tuned on a dyno or just flashed? Tell me in the comments. I want to hear about the good tunes and the horror stories. Take it easy out there.